To the video I have for you on the quotient rule. You are welcome to fill in the actual quotient rule in your notes now, but I'm gonna sing a little song. Lo d I minus I d lo, square the bottom and away we go. Okay, that is going platinum. Lo d high minus high d low, square the bottom and away we go. Please don't smile right now. You're doing math. Okay, so here's the deal. Look at this. The low, the bottom. Take the bottom times the derivative of the top. Subtract the top times the derivative of the bottom. All over, square the bottom, and away we go. So there we go. Low d high minus. Okay, let's go. First things first, let's try a sum and see how this is put to use. This is a quotient, this first one, but what we're trying to get you to understand by putting this one here is that you don't need to do the quotient rule. We actually had one like this before. You can break this up. X squared over x squared cancels, just makes 2. Plus, this would be 3 over x minus 4 over x squared. So then when you actually found the derivative here, derivative of any constant is, you said it, 0. Then we have x to the negative first, right? So when we have this here as 3x to the negative first, we bring the negative 1 out front, and then we multiply by the 3. So let me back that up. I meant to do that all in one step. So the negative 1 comes out front, so we have negative 3, and then we have x to the negative second power, so that's all going to go downstairs and become x squared. And then over here, this is really x to the negative second up top. So when we bring that, when we bring the negative 2 out front times the negative 4, we will get a positive 8. Hopefully we're getting better at the power rule, power down. So bring that negative 2, but that'll be a negative 3, so over a positive 3 in the bottom. So again, just to review, we can do that, but we can't on example 2. So here we go. We are going to find the derivative. I know my handwriting is not the best on this program. I'm sorry. So what do we have here? We're going to find the derivative of f of x over g of x. So take g of x, which in this case is just the denominator. So we just leave that as x squared plus 1. And then we multiply that by the derivative of the top. The derivative of the top is simply negative 1. And then we have minus the function, which is the numerator, correct? So we have simply 2 minus x, and then times the derivative of the denominator, which is 2x. All over, square the bottom, and away we go. So that would be x squared plus 1 squared. Okay, so what is that equivalent to? If you go through the top, we've got negative x squared, distributing that, minus 1. And then over here, if we think of this as a negative 2x here together, we can distribute the negative 2x through, and we will get a negative 4x and a positive 2x squared. I'm just going to leave the bottom in its factored form here, x squared plus 1 quantity squared. You never know, something might cancel at the end. And then we get what? We get x squared minus 4x minus 1 all over x squared plus 1 quantity squared. And there's no more work we can do to that to simplify that. So that is our derivative of this one. That's our first quotient rule. So now, obviously, you're going to need more practice as we go through those. But as we look into I had a hard time loading this up here, so I can't get rid of that stuff on the bottom, so I'm going to go and just go like this. You'll be able to figure it out. Okay, so now as we cruise through this, it basically says, hey, how do we do some of these other trig functions now that we know the quotient rule? Because if you look at all of these are quotients. So let's try them. Okay, so just ignore all of this now. So up here, isn't this the same as taking the derivative with respect to x there of, you guessed it, folks, sine of x over cosine of x. That's that one there. So now, what is this? Low d high minus high d low Square the bottom and away we go. So when we're doing this now, low cosine of x times the derivative of high, or the derivative of the top following your formula. Now I don't have it up here, but you might want to be looking, or hopefully you're looking at your formula, the quotient rule for how to do this. But again, we've got low derivative of sine of x, so that's just cosine of x, okay, minus high, which would be sine of x, times the derivative of the denominator, which is the opposite of sine x, all over denominator squared, so cosine x squared. So what is this equal to? Well, this would be equal to cosine squared x minus sine of x squared, wait, plus sine of x squared, all over cosine of x squared. And what is that top? 1. So what is the derivative of tangent? 1 over cosine squared x, which is equal to secant squared x. All right, one more. So let's do cotangent, and then I'll let you kind of discover the others. So the derivative with respect to x of cotangent would be cosine of x over sine of x. So very similar, this is a quotient. So low, whoops, that's my equal sign, low derivative of high, or derivative of the numerator, is opposite of sine x. Okay, low d high minus high cosine of x, d low cosine of x. Square the bottom and away we go. So sine squared of x. Well, if we look up at the top there, what do we have now? Well, you're going to have to get a little unique here in this, but can you see that we can actually factor out a -1? If I take a -1 out of here, that's going to be sine x squared, right? Take a -1 out, and then this would be plus cosine x squared. I need you to kind of see that. Again, distribute that through. That would be a negative sine squared. Distribute, or just multiply that, be a negative. So we definitely have negative sine squared minus cosine. That's exactly what we have right now. Just kind of looked a little differently there. And what do we got? We got sine squared x on the bottom. Well, what is this whole thing again? That's 1. So we have -1 over sine squared x, which would be the opposite of cosecant squared x. Okay, so we have the derivative of tangent being secant squared x, secant x squared, the derivative of cotangent x being the opposite of cosecant x squared. You try to get these other two and check the notes and see if you're doing them right.